Welcome to the lecture 1 of the module Economic Analysis of Water Supply Project. We will see a general overview, definition and origin of cost-benefit analysis, methodology of economic analysis, and some alternative to cost-benefit analysis. Overall, our aim in this module is to broaden the capacity for optimal resource allocation and the application of this knowledge in practices. Our focus being water supply project. In this lecture, the economic analysis of project will be examined and in particular the application of cost-benefit analysis. As will be seen, this is far from straightforward, and the complexity of applying cost-benefit analysis to a particular project require careful consideration. Trends in the use of CBA have varied over the years with some radical change in emphasis. This and alternative to CBA will be touched upon. A deep understanding of this economic analysis is vital as, in our experience, the economic analysis applied to energy and transportation projects tend to be more effective than of projects involving water supply and sanitation. In general terms, agriculture and projects involving natural resources are the fields with most room for improvement. Before looking at the specific component of the cost-benefit analysis in detail, a first and extremely important aspect of it needs to be stressed. To view a CBA as something equal to a balance sheet with a figure in dollars and cents at the bottom would be a crossover simplification. These are many and various more nebulous concepts involved. The starting point for project economic analysis or cost-benefit analysis is that the financial perspective alone will not capture the gains to society and that a quantitative assessment of economic cost and benefit is necessary. Financial measures can be highly misleading as indicators of the social welfare improvement of a project. This is because key outputs from many projects are either not sold on a market, for example, no toll roads, solid waste management, reduction in air and water pollution, health improvement from water supply and sanitation, or are sold in distorted or controlled markets. For example, water and electricity sales subject to administrative pricing. Project economic analysis is an analytical framework from converting costs and benefits of a project to comparable monetary units, so they can be compared systematically and incorporated in a measure of project worth. It originated in the analysis of water resources projects in the United States in the 1930s, and, as discussed below, retains its relevance in the context of higher income economies. More broadly, market failure provides the fundamental reason for undertaking CBA. The divergence created between private and social costs and benefits due to market failure results in prices that do not reveal marginal social costs or benefits. Thus, financial analysis undertaken with such prices is inadequate as a means of judging the efficiency of resource allocation. However, donor agencies and governments sometimes go beyond this requirement. In particular, the environmental and social safeguard policies of donors have made it a requirement to compensate for certain types of easily identifiable losses of projects. The early literature on CBA was ambitious in this sense, that it aimed to assess projects not just from the allocative efficiency viewpoint, but also in terms of their contribution to growth through higher saving and reinvested income, and redistribution through higher income for poorer groups. If an analysis is to capture diverse effects, this requires such effects be converted into a common unit of account or numerator. Thus, diverse effects on short-run resources allocation, growth, and redistribution need to be weighted and combined in a single measure. The original methodology of economic analysis has been extended in a number of ways in recent decades. This section focuses on several of these: income distribution and poverty, risk and uncertainty, valuation of non-market goods, environmental sustainability, discounting. Attitudes toward incorporation of distribution and poverty reduction objectives in project decision-making have changed over time with shift in aid fashion. The original methodology was developed and applied initially in the 1970s during the World Bank presidency of Robert McNamara, with poverty reduction as the main focus of development assistance. However, during the 90s, this focus became diluted, with the emphasis turning to macroeconomic reforms and debt rescheduling. Initially, the principal focus was on an adjustment to the shadow wage on the grounds that the main increase in consumption created by a project would be through payment to unskilled workers in excess of their opportunity cost. Since the labor surplus argument was applied, it was assumed that the gap between formal sector wages paid by a project and their alternative marginal product would be high and that this extra income would be consumed. This procedure of introducing wages into the economic prices of labor has been highly controversial and complex, with many adjustments introduced in a single equation. The most important shortcoming is the lack of objective in selecting the elasticity that reflects the declining social worth of an extra income as the consumption level of the project beneficiaries rises. The approach utilizing differential ways is only partial because any project will have distributional effects that go beyond just the extra income going to unskilled workers. For example, with gain to consumers, investors, and governments. A comprehensive analysis requires disaggregating the net income change created by a project, its economic net present value, into changes for different groups. These income changes can then be decomposed into changes in consumption and saving, and, if necessary, different weight can be applied to this. Thus, for a project involving 4 groups of stakeholders, for example, A. Workers, B. Consumers, C. Investors, and D. Government, the formula is the one shown.